Good morning, everyone. This is Miss Bradfield. We're going to finish up the lesson on 6-4 over rectangles. Yesterday we talked about rectangles being a quadrilateral with 4 right angles and having all the properties of a parallelogram. So technically it's a parallelogram with 4 right angles. And so we have all of the properties of a parallelogram. Opposite sides are parallel, opposite angles are congruent, opposite sides are congruent, consecutive angles are supplementary, and the diagonals bisect each other. Then we added, because this is a rectangle, that we have all 4 angles are right angles, and that the diagonals are congruent. So our diagonals are SU and TR, and they are congruent to each other. Because of that, we also figured out that since the diagonals bisect each other, we have congruent parts, but since they're also congruent, our other pair of diagonals that are divided into congruent parts are all equal to the other diagonal. So we actually end up with 4 congruent segments such that TQ, RQ, SQ, and UQ are all congruent to each other. Then we worked the first 2 examples, and for some classes we started this, extra exercises. So let's look at number 1. We have BE and CE. We want to find the value of Y. Well, here's BE and here's CE. And as we learned above, since the diagonals bisect each other and they're congruent, we had a bunch of congruent segments. So that means that BE and CE are congruent to each other. Therefore, BE is equal to CE. And we're just going to then plug in the values. That was the geometry part. When we plug in the values, I'm going to get 6y plus 2 equals 4y plus 6, and then we can solve. So variables on left, and we're going to subtract 4y. So I get 2y plus 2 equals 6. And then we're going to do our constants on the right. So we're going to subtract 2 here. And I get 2y equals 4. And then we're going to divide by 2, which gives me y equals 2. So for number 1, y equals 2. All right, let's take a look at number 2. For number 2, we have some angles, and we have that BEA, so we have to identify that. BEA is 62 degrees, and we want to find BAC. This is angle BAC here. So we actually want to find this angle. Well, yesterday we talked about the fact that we had a bunch of triangles, and we actually found out that these were isosceles triangles. So we're just going to focus on the fact that we have an isosceles triangle right here. Because it's an isosceles triangle by the isosceles triangle theorem, these base angles are congruent. So what I'm going to do is I'm going to put an x here and an x here because they're the same value. So for my triangle, I have angles x, x, and 62. And I know the sum of the interior angles of a triangle is 180. So for number 2, to solve for BAC or x, I'm going to take x plus 62 equals 180. And then that's the geometry part. Then we're going to do some algebra. Combine like terms. This is 2x plus 62 equals 180. We already have one variable on the left, so we're going to do constant on the right. 2x then is a 118. And then we're going to divide by 2. x equals 59. So our equation again is that x plus 62 equal to 180 degrees. Then x is 59 degrees, which is the measure of angle BAC. Number 3, we have the measure of angle AED. So I'm going to highlight that. AED, so this angle right here, and BEC, this angle. Well, these two are vertical angles. So this is actually using the vertical angle theorem, which means these two angles are congruent and have the same measure. So the measure of angle AED is going to equal the measure of angle BEC by the vertical angle theorem. Then to solve that, we're just going to plug those values back in. 12x is for AED, BEC is 10x plus 20. Variables on the left. I'm going to subtract 10x. 2x equals 20. And then we're going to divide by 2. X equals 10. Now that's x. We want the measure of angle AED, okay, which was 12x. So I'm going to take 12 times 10 because x was 10, which is 120 degrees. So we get the measure of AED, which is 120 degrees. And we'll fill that in. All right, and then for number 4, it says AB equals 6y, BC equals 8y. So these are segments this time. AB is 6y, BC is 8y. We want to find BD. So this is kind of a tricky one. Let's remember that all of the angles are right angles and that the diagonals are congruent. Okay, so the length of CA is the same as the length of BD. So what I want to do is I'm going to focus on the fact that I have a right triangle, and CA, which again is the same as BD, is the hypotenuse. I'm going to use the Pythagorean theorem. Remember, the Pythagorean theorem is a squared plus b squared equals c squared. A and B are the legs, and C is the hypotenuse, which is what I want to find. Now, it does say in terms of y, so what that means is we're not actually going to solve for a specific number. There's going to be a y in it. So we're going to let A be the 6y and B be the 8y and then c squared. So we're solving for c. That's what we want to get, c by itself. I need to simplify a little bit. I've got 36y squared plus 64 y squared equals c squared. Now these both have a y squared, so these are like terms, which means I'm going to add them together. And that gives me 42 y squared equals c squared. And we're going to take the square root. So we have the square root of 42, and the square root of y squared is y. So we could put that c, or the hypotenuse, is y square root of 42. It can be simplified. Actually, I don't think 42 can be simplified. So we're going to just leave it as y square root of 42. So c, or BD, is equal to y square root of 42. And how we got that is by using 6y squared plus 8y squared equals c squared. All right, let's look at the other side. And it says prove that the parallelograms are rectangles. This is where we're going to go and we're going to use GeoGebra to solve for these values. And so I'm going to open up GeoGebra and we're going to plug these values in and find the slope for this. And then we're going to try it using the distance formula and find the length.